Does this happen with covalent bonds? Well, it actually doesn't. The only covalent compound that I gave you in this lab was sugar, the sucrose. It turns out that this is the rare example of covalent compound that actually does dissolve in water. Most of them don't. Think about like if you were to put oil in a cup of water, it wouldn't dissolve. They would just be separate, right? So what happens in the sugar solution is these black things, you can't really see them very well, but these black sugar molecules, or I'm sorry, this whole thing is the sugar molecule. Okay, sugar is made of carbon, hydrogen, and oxygen. All right, so you can see this similar things happen here where there is like a partial charge here, but that's why sugar dissolves. But the individual atoms of this molecule, sugar molecule, do not come apart like they do over here in a ionic solution. Okay, so I hope that difference is evident and it makes sense. Let me know if you still are struggling with this concept. And then metal bonds, we don't really talk about them too much just because they're kind of really unique. The only things that you really need to know about them is these metals don't end up filling their valence shells, so they end up sharing all of these electrons, but they're not full, and none of them are full. Okay, so we call this a sea or a cloud. You can see these electrons are kind of just being shared between all of them. So our cations are staying in our positively charged ions, also called cations, they're staying in a fixed position, and then these electrons are floating around between them. Okay, this is why they conduct electricity, because we have positive and negatives all over the place. All right. This is also why, if you watch that Edpuzzle video, they're very malleable. You can move them around, you can make them ductile, they're good conductors of heat. So this whole thing is basically why metals have those unique properties. And then alloys, when we're combining metals with each other, it makes them stronger because you end up having the properties of both of the metals you're combining essentially combine for a greater force. Okay. Then this week, the Kuleana for this week, this is what we did today. Tomorrow, you're going to do this bonds practice worksheet. I'm going to go over that in a second. Wednesday, a concept map, and I'll have a short review puzzle just to review the homework questions. Thursday, you're going to take a quiz. Friday, we're going to start 7.1. Okay, so this worksheet, I put it in the Chapter 6 Schoology folder. Essentially, I'm just going to go over the steps of how to do each one of these. One side is ionic, one side is covalent. And since you guys are at home, what I want you to do is look at the worksheet, but I want you to write down the answers on paper and then send me a picture of them, because you're going to learn this better if you're writing it and practicing it. Okay, so for each one of these, this is the ionic side. You're going to follow the directions here. The first step is you're going to write the symbols for each element. Here's sodium and here's chlorine. Then you're going to draw the Lewis dot structure. Remember, you're going to look at your periodic table to figure out how many valence electrons. We have 1 with sodium, 7 with chlorine. You're going to draw an arrow for the direction that the electron is transferred. In this case, chlorine is stealing sodium, so it goes from there to there. Next, you're going to draw an arrow. This just means after the bond. You're going to write the charges you're going to write the resulting charges. So sodium loses an electron, so now it has a positive charge. Chlorine gains 1, so now it has an extra negative charge. Okay, and then for our covalent side, it's just a little bit different. You're going to, same thing, write the symbol, draw the Lewis dot structures for each element, rearrange the electrons to pair them up for each atom, and then I want you to circle the ones that are paired. Okay, this is a really easy one, but you're going to have some bigger molecules here. And then the last part on here is to use chemical symbols and lines. So this line means 2 shared electrons. Okay, so they're sharing them here. You can see by the colors. You don't have to use different colors, but you can if it helps you keep things organized. And then over here, this is what the bond looks like essentially. You just have two hydrogen ions bonded together, they're sharing 2 electrons. And then I didn't do this last part, write the chemical formula for each molecule. That would just be H with a tiny little 2 next to it. So H2, okay? And that's it for this week. If you're struggling with this bond practice worksheet, I'm going to have a review session Wednesday morning at 9 a.m. in a Schoology conference. So pop in if you need some help or extra tutoring or extra support or just want to say hi or anything like that. Okay, let me know if you guys have any questions on this. Have a good day. Bye.